It is now my honor to introduce to you Arun Alagappan. Arun is president and founder of Advantage Testing, president of the Board of Trustees of the Advantage Testing Foundation, and co-creator of the Advantage Testing Foundation Math Prize for Girls competition. Arun graduated Phi Beta Kappa from Princeton University and went on to graduate from Harvard Law School, where he served as editor of the Harvard International Law Journal. While at Harvard, Arun was also an instructor in the math department, and he was awarded a Certificate of Distinction for outstanding teaching of undergraduates from the Dean of Harvard College. Soon after, Arun came to his senses and realized that his true calling was as an educator. And in 1986, he founded Advantage Testing. Arun was one of 7 educators featured in New York Magazine's The Influentials, a cover story identifying more than 200 professionals whose ideas, power, and sheer will are changing New York. In 2011, he was profiled in the Wall Street Journal for helping to find the next generation of leaders who will bring diversity, new ideas, compassion, and a different kind of leadership to institutions. Arun has personally tutored, mentored, and guided thousands of students throughout their academic careers. He has made outstanding tutoring available to thousands more through the Advantage Testing Foundation's partnerships with such programs as LEADA, the Leadership Enterprise for a Diverse America, and Prep for Prep, and through its own flagship programs, our Math Prize for Girls, and Trials, the Training and Recruitment Initiative for admission to leading law schools. So after such a long list of accomplishments, I grant a warm welcome to Arun Alagappan.
Welcome, everyone, to the 2015 Advantage Testing Foundation Math Prize for Girls, the largest math prize for girls in the world. Before I begin, I want to remind you there are 3 kinds of people in the world: those who can count and those who can't. That's really important because math illiteracy affects 5 out of 3 adults each year. And that's really sad because I love math. In fact, just this morning, my wife asked me, "Do you love math more than you love me?" "Of course not, dear," I replied. "I love you much, much more." "Then prove it," she said. "Okay," I replied. "Let R be the finite set of all lovable objects." Thank you, Elena Cherkayev, for those jokes. Moving on to more serious matters. Today is our 7th annual Math Prize for Girls and our 5th year in a row at MIT. Thank you to MIT President Reif and the entire MIT community for partnering with the AT Foundation to identify, reward, and encourage the next generation of leaders in STEM. I'm delighted that so many of the girls who first encountered MIT at our Math Prize returned to MIT as undergraduate college students. My deep gratitude to Michael Sipser, now Dean of the MIT School of Science, who has served on the advisory board of the AT Foundation Math Prize for Girls since we began. Michael was instrumental in bringing our Math Prize here. I'm also delighted to welcome Dr. Tom Murovka, head of the mathematics department at MIT. Thank you, Tom, for your department's continued strong advocacy of our prize and for speaking to the girls today. Our Math Prize for Girls community also knows how to throw a party. Many people help to make the weekend a wonderful celebration. A shout out to the families who are cheering you girls on today and to the teachers who have supported and inspired you. Thank you to the many, many volunteers from MIT, from AT, and the AT Foundation. Thanks especially to the Sisterhood of the Traveling Polynomials, our outstanding alumni who serve as enthusiastic volunteers and generous mentors. Thank you to our terrific MC, Math Prize alumna, Jackie Breedenberg. Thank you to the Logarithms, our favorite guys at the Math Prize for Girls. I'm also pleased to acknowledge the Akamai Foundation and Wolfram Mathematica early and enduring supporters who are committed to helping talented young mathematicians succeed. Of course, I want to convey our collective sense of gratitude to Maria D. Vuono Hamburg, Associate Director of the Math Prize for Girls. With efficiency, intelligence, charm, and grace, Maria truly runs the show. And finally, I express my deep AAA admiration, appreciation, and affection for my colleague, Dr. Ravi Bopanna, the creative force behind this prize and the primary author of all 7 Math Prize for Girls tests. And how about a round of applause for all of you, the 270 girls who traveled from 32 states, including Alaska and 2 Canadian provinces, our mathematical superstars in the house. This past summer, the US women's soccer team captivated the nation as they dominated the World Cup. Fans and sportscasters hailed midfielder Carly Lloyd as the team's shining star. She propelled the US women to victory with an unprecedented hat trick, scoring 3 goals in the first 16 minutes of the final match. President Obama sent Carly a congratulatory tweet and invited her to the White House. A reporter described a sensational goal she hit from midfield as, quote, the most remarkable ever witnessed in the history of the Women's World Cup. At this point, some of you may be thinking, Arun, what does Carly Lloyd have to do with math? Well, in the final match, Carly Lloyd attained a state of mind and body that athletes refer to as, quote, being in the zone, unquote. When a soccer star is in the zone, the clock appears to slow down as she times her run to perfection, leaves her opponent scrambling, and scores past a diving goalie. In mathematics, the analogous phenomenon is the aha or eureka moment, the exhilaration you feel when something clicks and you unlock a seemingly impenetrable puzzle. Some of you may have been in the zone this morning while wrestling with Ravi's little quiz. Answering some of those questions is like scoring a goal, isn't it? To many, of course, Carly's soccer achievements appeared effortless. But at 33 years old, Carly Lloyd has been honing her game for nearly 3 decades. Her workouts are as grueling as her standards are high. As young mathematicians, you understand that to attain a goal, you must first work. You must seek out challenges and exercise your minds. Today, we pause to recognize your talent. We celebrate the years of hard work and study you have put into to achieve in this subject, mathematics. So let's put to rest the myth that the best athletes, the best thinkers, display, quote, effortless perfection, unquote. And let's once and for all obliterate the myth that math is only for boys and for men. Rather, let's embrace the truth. Work hard, work cheerfully, and you too can level the playing field and you can succeed. The Japanese novelist Yoko Ogawa compares solving a mathematical problem to, quote, climbing a mountain with a guide along a trail someone else has laid. She writes, in mathematics, the truth is somewhere out there, beyond all the beaten paths, and it's not always at the top of the mountain. It might be in a crack or the smoothest cliff or somewhere deep in the valley. As you pursue your mathematical journeys, remember, our Math Prize for Girls community offers brilliant mathematicians and scientists to serve as your guides. You'll hear from Dr. Sarah Seeger today, a 2013 MacArthur Fellow and Professor of Planetary Science and Physics at MIT. Dr. Seeger pursues research far beyond the Earth's highest summits. She studies exoplanet atmospheres, interiors, and biosignatures in search of planets with signs of life. You can find inspiration in the stories of such extraordinary mathematicians, engineers, and scientists who have come before you, including the brilliant chair of the MIT math department today. In the past few years, historians have brought attention to the role of women in early computer programming. In 1945, Jean Jennings, then a recent college graduate, spotted a classified ad in her school's newspaper, "Wanted, women with degrees in mathematics." During World War II, with able-bodied men enlisted as soldiers, the US experienced a labor shortage that forced the nation to rethink its sexist practice of excluding women from high-skilled jobs. Jean Jennings answered the ad's call. Hours after learning via telegraph that she had been accepted, she boarded a train for Pennsylvania to serve as, quote, "a human computer," unquote. The Army hired her to perform calculations by hand, but soon after arriving, Jennings was assigned to a top-secret project under development at the University of Pennsylvania's Moore School of Engineering. The Electronic Numerical Integrator and Computer, or ENIAC, was the world's first general-purpose computer. The huge machine occupied a room 30 by 50 feet in size. It weighed 30 tons and consisted of 40 panels, 18,000 vacuum tubes, 500,000 soldered joints, 70,000 resistors, and 10,000 capacitors. Jennings and her 5 female colleagues received 6 weeks of training and stacks of blueprints for ENIAC. Through demanding days and late nights, the women learned to interface with the machine. They broke down complicated math problems into small, performable steps and manually configured the cables and switches to produce calculations. As Jennings and her colleagues debugged and coaxed new tasks out of the hardware, they pioneered modern computer programming. Thankfully, our nation has evolved since the 1940s. Following World War II, we imagined uses for the computer far nobler than that of war. At the same time, most of us now recognize that the idea that the best scientists, the best technologists, the best engineers, and the best mathematicians might all emerge from an all-male population is ridiculous. Only by selecting the leading men and women from every background can we hope to develop true leaders in every field. Indeed, study after study has confirmed that the nations that consistently perform the best on international tests in math and science are those in which there is less pronounced disparity in performance among men and women in those disciplines. Walter Isaacson writes stirringly about Jean Jennings and her colleagues in The Innovators, his recent study of the women and men behind the creation of the computer and the internet. The next discoveries, he predicts, will come from people who are able to, quote, link beauty to engineering, humanity to technology, and poetry to processors. Girls, you are our nation's next generation of innovators. You will yield the next big breakthroughs in science, computing, astrophysics, engineering, biotechnology, and clean energy. By collaborating with your peers, by bringing passion and creativity to your pursuits, and by pursuing difficult problems with grit and determination, you will answer the call, quote, "Wanted, women, to advance the irresistible and noble subject of mathematics," unquote. May the wind be behind your backs, and may the force be with you.